Okay, here's the last thing, and we can go through those 7 things which you have to go through, okay? This is the last thing we gotta know in prerequisite. Find the stationary points, point number 1, on the curve and determine their nature. You see, I've put in blue the second part. Determine their nature. That's the second part, okay? I expect you to be already knowing this is just a recap. So anyway, we have our curve y is equal to x cubed minus 3x squared plus 2. Now, what we know is that if I differentiate, I'm going to get the gradient. And now, how does that help me? Because they want me to find stationary points. I know that stationary point is the point where my curve turns, right? And the point where my curve turns here, this point, the gradient, you see this line I'm putting, that's your tangent. The gradient is 0 because it's a flat line, okay? The point where your curve turns here, that's the stationary point. And at that point, the curve is flat. So the gradient would be 0, okay? The gradient would be 0 at the turning point. So that's one thing I already know. So that means if I find my derivative dy dx, I should make it equal to 0 because I know at turning point, my gradient is 0. Now here they want points to mean this curve turns more than once. And that is true. A curve of x cubed is either this one or it's like this. Okay? For curve for x squared, when they say y is equal to x squared, blah, 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 x squared being the highest power, like power of 2, then it's either going to smile or frown. Okay? It's going to be a parabola. So this is what it does. It's a parabola. Either it's going to be like this or like, so it only turns once. So they would ask for one stationary point here. But when the curve is an x cubed, then we know it turns here and there. So it has 2. So you're going to have here, then there. So you're going to have to find and tell us that this one is it, a maximum or minimum. Remember, this would be maximum because it's turning at the highest point. And then here, since it's turning at the lowest point, it will be a minimum. So we are just going ahead to find those. Let's go ahead and let's find them again. So we have our curve. First thing we do is to differentiate dy dx. It is going to be, we differentiate. This is easy to differentiate, right? Bring down the power, 3x to the 2. The power reduces by 1. Then minus here, because there's a number you multiply. 2 by 3, 6. You reduce the power by 1, x to the 1. Derivative of 2 is 0. So that means it's 3x squared minus 6x. Then I know I'll stay for stationary points, for me to find the stationary points, say let dy dx, let my gradient be equal to 0. Because I know that at the turning point, my gradient is 0 because it's a flat line. It's flat at the turning point. So even if I see the tangent, it tells me that the gradient is 0 because it's a flat line. There's no slope. So I can say now 3x squared, that's my dy dx, 3x squared minus 6x is equal to 0. How do I solve this? You can go and see the videos on factorization, okay? That's topic 1 of paper 1. I bring out here 3, here x, because this is a quadratic equation and I can solve either by factorization or quadratic formula, okay? Those are the ones I use. Although I can also do completing the square, but I use factorization or quadratic formula. Here I'm factorizing. 3 is common in 3 and 6, and x is common in x squared and x. So I'll say 3 into 3, 1. X into x squared, I'll remain with just 1x and x. Okay, because x squared is 2x's multiplying. I'm removing 1, so I will remain with 1. Then minus 3 into 6, 2. Then x into x is 1, so this will be equal to 0. Now, when two numbers multiply to give me 0, either one is 0 or both are 0. So I'm going to say 3x is equal to 0 or x minus 2 is equal to 0. So I would have it as 3x giving me 0. X will be equal to 0 over 3 because 3 goes to the other side to divide. X will be equal to 0. Or minus 2 goes to the other side. X will be equal to 2. So I have my 2 points. Stationary points, x equal to 0 and x equal to 2. But when they say point, That means I also need the y coordinate. So I'm going to bring this again because point is x comma y. Okay, so I need the y coordinate, right? Let's see. Y is equal to x cubed minus 3x squared plus 2. So I'll say y is equal to x cubed minus 3x squared plus 2. Now I'll say when x is equal to 0, y will be equal to wherever there is x, I'm putting 0. So it'll be 0 cubed minus 3 by 0 squared plus 2. Y will be equal to wherever there is 0. This is 0 cubed. Then 3 times 0. 0 squared is just 0. 3 times 0 is 0. Any number times 0 is 0. Then I'll remain with plus 2. Just the 2 at the end. So it will be just this 2. So that means I have 0, 2 as my point. So I'll say now, when x is equal to, that means this first point I have 0, 2, right? X 0, y 2. Then now I say when x is 2, that means y is equal to 2 cubed. I'm putting 2 for x here. Minus 3 by 2 squared plus 2, which is going to be 2 cubed is 8 minus 3 by 2 squared is 4, then plus 2. It will be 8 minus 3 by 4 is 12, then plus 2. 8 minus 12 is negative 4. You can do the math, okay? Plus 2, you get minus 2. So y will be minus 2. So I can have my other point is 2, negative 2. x2, y negative 2, okay? Now I do the last part which says determine their nature. Okay, so I can now say for nature, okay? For nature of points. Okay, for nature of points, I would say now dy dx. First, dy dx is equal to what? What is my first derivative? Dy dx, it is 3x squared minus 6x. Okay, so it is equal to 3x squared minus 6x. That means now for me to get nature, I need to get the second derivative. So I'll say d2y dx squared is equal to, that is the second derivative. I differentiate this again. 2 times 3, 6, x to the power of 1. Derivative of minus 6x is just minus 6. Okay, I'm differentiating this dy dx again. Okay, I would say 2 times 3 is 6, then x becomes the power of 1. Derivative of minus 6x is just minus 6. Now I would say when x is equal to 0, okay, I'll start with this first point, right? x0. I'm going to see what type of a turning point it is. I would say now d2y dx squared is equal to 6 by 0 minus 6, which is 6 by 0 is 0, then minus 6, it will be minus 6. So you see, it's a negative number, okay? And what it means is if you get, remember the conditions which we use. You can go and check again. Here are the conditions. If d2y dx squared is greater than 0, if the second derivative is greater than 0, that means when you put x, isn't here we've tried, when x is 0, we put it into the second derivative, isn't? And we found an answer that is less than 0, right? So that means here it is less than 0. Okay, here the conditions say when it's greater than 0, that means your guy is going to smile. So that means your curve is smiling. Because he is greater than 0, he is happy, he is smiling. And when he is smiling, what type of a turning point is this? It's a minimum. Okay, it's a minimum. Don't ever make a mistake. Okay, so this leads to a minimum because the curve is smiling, so you just say minimum. Then you say if d2y dx squared is less than 0, then is it going to be happy? No, it's going to frown. Okay, and when it frowns, here is the curve. This is a maximum turning point. So it leads to a maximum because it will turn at its highest position. So here I would now say, therefore, you can say therefore 0, x being 0, what was the y? 2. Y was 2. Okay, so therefore 0, 2 is a maximum. Okay, you can say it's a maximum. Okay, since d2y dx squared, is less than 0, so it's unhappy, so it's going to have a maximum. Okay, then you can now say when x is equal to 2, d2y dx squared, let's find it, d2y dx squared, this is going to be equal to 6 by 2 minus 6, okay, which is going to be, remember, where there is x, we are now putting 2. We are now doing for this point, x2, this point. That's the one we are doing for. When x is equal to, so you take 6 by 2, that's 12 minus 6, which is 12 minus 6 is 6. So you can now say, therefore, 2 comma negative 2, remember that's the point. X was 2 and y was negative 2 here. That's the point. So 2 comma negative 2 is a minimum. Okay, it is a minimum turning point or stationary point. Okay, stationary point. Why? Why is it a minimum? Since d2y dx squared is less than 0. Okay, when it's greater than 0, sorry. It's a positive number, so that means it's greater than 0, and he's going to smile. And when he smiles, it's going to give you a minimum. Don't ever forget that. Okay, so these are your things, and you are done. You have found the turning points and their nature. Well done.